Now in this video we'll be talking about polynomial multiplication. Now two of the properties that we need when we're talking about multiplying polynomials are multiplying like bases and the distributive property. So first of all, for multiplying like bases, if you have something that looks like x to the n power times x to the m power, then that's really just x to the n plus m power. Now, just to recall just a little bit, when we have something like x to the n power, then the x is called the base, and that's really what's being multiplied. Now, the n is the exponent, and that's really the number of times that we're multiplying. And so when we say that we are multiplying like bases, we just mean that the bases are exactly the same. The bases match. And so kind of the English phrase that we can keep in our heads, the rule for making this work, multiplying like bases, you add the exponents. Now, the second property that we use when multiplying polynomials is the distributive property. Now, everybody pretty much remembers this, that if we've got something like a times the quantity b plus c, then we imagine that a is getting distributed to the b and to the c. And so the distributive property tells us that we've got a times b plus the a times the c. So let's see exactly how this works with our polynomials. Suppose we're asked to multiply x to the fourth times x to the fifth. Well, when we see x to the fourth, we know that we're multiplying 4 x's together. When we see x to the fifth, we know that we're multiplying 5 x's together. And so multiplying like bases, we add the exponents. So that's going to be x to the 4 plus 5. 4 plus 5 gives us x to the ninth. And really kind of what we're doing, it's more like a bookkeeping way of keeping track of how many x's that we're multiplying. If we're multiplying 4, then we're multiplying 5. The total that we're multiplying is 9. So 4 x's times 5 x's gives us 9 x's that we're multiplying together. So x to the fourth times x to the fifth gives us x to the ninth. So kind of some more examples. If we had y to the third power times y to the eighth power, we just add the exponents together. 3 plus 8 gives us y to the 11th power. So we've got 3 y's that we're multiplying, 8 y's that we're multiplying. So we've got a total of 3 plus 8, or 11 y's that we're multiplying. Another example, if we're multiplying y to the 8th times y to the 12th, well, again, 8 plus 12 is going to give us 20, so we have y to the 20th power. Now, if we have two variables, suppose we've got an x to the third times y to the fourth times our x to the seventh times our y to the eighth. Well, we can group the x's together, so x to the third times x to the seventh, and we can group the y's together, y to the fourth times y to the eighth, and then we're just adding the exponents for the like bases. So how many x's do we have total? 7 plus 3 gives us x to the 10th. 4 plus 8 y's gives us y to the 12th power. And so we can put the like bases together to make it a little easier for us to see, but in the end, for the final answer, we're really just adding all of the exponents on the x's together. We're just adding all of the exponents on the y's together. So another example, suppose we've got 3x to the fourth times 5x to the sixth. Well, the 3 and the 5 are just coefficients. They're just being multiplied, 3 times 5, so that's going to give us 15. And then how many total x's are we multiplying? Well, we're multiplying 4 in the first batch, 6 in the second batch, so we've got a total of 10 x's that we're multiplying. And so kind of the punchline for those, you are multiplying the coefficients and you're adding the exponents. So a second example, if we've got a negative 7z to the third times 4z to the 10th, negative 4 times 7, or negative 7 times 4 gives us negative 28. We add the exponents. 3 plus 10 gives us z to the 13th. Third example, if we have 2x to the 8th times 3x to the 7th, we multiply the coefficients, the 2 and the 3. 2 times 3 gives us 6. We add the exponents. 8 plus 7 gives us 15. So we've got 6x to the 15th power. Kind of our last example there, we've got a -4, a -5y to the 4th, and a -6y to the 12th. When we multiply the coefficients, so -5 times -6 gives us a positive 30, and we add the exponents. 4 plus 12 gives us 16. So we've got a 30y to the 16th power. So a slightly more complicated example, suppose now that we've got 4x squared times the quantity 3x to the 4th plus 2x. Well, the distributive property tells us that the 4x squared is going to multiply both terms. It's going to multiply the 3x to the 4th, and it's going to multiply the 2x. So we've got a 4x squared times 3x to the 4th plus our 4x squared times 2x. Now, just like in the previous example, we multiply the coefficients, we add the exponents. 4 times 3 gives us 12x to the 6th. 4 times 2 gives us 8. 2 plus 1 gives us 3, so we've got 8x to the 3rd power. So our final answer, 12x to the 6th plus 8x to the 3rd. Another example along those same lines, suppose that we're multiplying 2y to the 3rd power times the quantity 5y plus 4. Well, again, the distributive property says that we'll have the 2y, and it's going to get distributed to the 5y and to the 4. So we've got 2y to the 3rd power times 5y plus 2y to the 3rd power times 4. Multiply coefficients, add the exponents, so 2 times 5 gives us 10, y to the 4th power. Multiplying coefficients, adding exponents, 4 times 2 gives us 8, y to the 3rd power. So our final answer, 10y to the 4th plus 8y cubed. So what about an example where we're actually dealing with subtraction? Well, suppose we've got 3z times the quantity 7z minus 4. Well, again, we're using the distributive property. 3z will distribute to the 7z, and the 3z will distribute to the -4. So that's going to give us a 3z times 7z plus a 3z times the -4. The thing to remember here with subtraction is that we always think of subtraction as the subtraction abbreviation. So when we see -4, we're really thinking that we're adding on a -4 in that case. And so that's why we're going to add on 3z times the -4. So just like before, multiply coefficients, add the exponents. 3 times 7 gives us 21z squared plus 3 times the -4 gives us a -12z. And so since we're adding on a negative, we can go back to our subtraction abbreviation and write that as our final answer as 21z squared minus the 12z. So again, kind of another one of those examples. Suppose that we have a -4x squared times the quantity 3x cubed minus 2x. Well, applying the distributive property, the -4x squared is going to get distributed to the 3x cubed, and it's going to get distributed to the -2x. So that we would have -4x squared times 3x cubed plus the -4x squared times the -2x. And so multiplying coefficients, adding exponents, -4 times 3 gives us a -12. X squared times x cubed gives us x to the 5th. -4 times -2 gives us a positive 8. X squared times x gives us x cubed. So we get a final answer of -12x to the 5th plus our 8x cubed. So let's do one more example where kind of increase the volume a little bit more, and so maybe we're multiplying by 3 terms. So suppose we've got 3x squared times the quantity 4x squared minus 3x minus 7. Well, the distributive property tells us that the 3x squared is going to get distributed to all three terms. So we've got a 3x squared times the 4x squared. We've got a 3 plus our 3x squared times our negative 3x plus a 3x squared times the negative 7. Okay. Now, multiplying coefficients, adding exponents. 3 times 4 gives us 12. X squared times x squared gives us x to the 4th. Plus a 3 times a negative 3 gives us a negative 9. X squared times x gives us x cubed. Plus our 3 times a negative 7 gives us a negative 21. And our x squared just stays as our x squared. Now we can use our subtraction abbreviation again so that we can have our final answer as 12x to the 4th power minus 9x cubed minus 21x squared. Now let's look at an example where we're multiplying two terms times two terms. So suppose we're multiplying our quantity 2x plus 3 times the quantity 4x plus 5. Well, now what's being distributed, we can think of that entire 2x plus 3 as being one object. It's in parentheses, so we treat it as one object, so that one object gets distributed to the 4x, and that one object is getting distributed to the 5. And so we will have the quantity 2x plus 3 times our 4x plus the quantity 2x plus 3 times 5. Well, we use distribution one time, we can use it a couple of more times. So the 4x is going to get distributed to the 2x, the 4x is going to get distributed to the 3. Then in the second one, we're going to have the 5 getting distributed to the 2x, and the 5 being distributed to the 3. So that's going to give us 2x times 4x plus 3 times our 4x plus our 2x times our 5 plus our 3 times our 5. Multiplying coefficients, adding exponents gives us 8x squared. 3 times 4 gives us 12 times x. 2x times 5 gives us 10x. And 3 times 5 gives us 15. Now in this case, we've got our 12x plus our 10x. We can combine those like terms to give us 8x squared. The 12 plus the 10 gives us 22 x's plus our 15. So I can hear maybe some people out there who are saying, well, what about FOIL? I learned FOIL in high school. What about that? Well, what exactly is FOIL? FOIL is a way of remembering which combinations of terms to multiply. That when we see FOIL, that's really the F is standing for the first two terms. The O is standing for the outside two terms. I is for the inside terms, and L is for the last two terms. So if we look at that example again, we've got our 2x plus 3 times our 4x plus 5. The F would mean that we take the 2x times the 4x. The O would tell us that we take the outside two terms, the 2x times the 5. The I for the inside terms gives us 3 times our 4x. And the L for the last two terms gives us 3 times 5. So the combinations that we have, 2x times 4x for the F, 2x times 5 for the outside terms, 3 times 4x for the inside terms, and 3 times 5 for the last two terms. Still multiplying coefficients, adding exponents. We get 2 times 4 is 8. X times x gives us x squared. Plus 2 times 5 gives us 10 times x. Plus 3 times 4 gives us 12 times x. Plus the 3 times 5 gives us our 15. Again, combining the 10x and the 12x as like terms, we have 8x squared plus 22x plus 15. Well, the problem with FOIL is that it's a special case and it only works when we are multiplying two terms by two terms. Now, that's not always what we encounter. For example, when we had the last one where we had our 2x plus 3 times our 4x plus 5, we had two terms in the first set of parentheses, two terms in the second set of parentheses, and so FOIL will work in that case. Where it doesn't work, and why I don't really like it, because it's limited to only those two cases, or only that one case where it's a two term by two term, is when we have something like 2x plus 3 times 4x squared plus 5x plus 6. In this case, FOIL fails, because in our second set of parentheses, we have first, the middle term, and the last term. And the problem with FOIL is there is no M in FOIL. So that's why FOIL is a special case. It's taught in high schools and junior high schools all of the time. It's really kind of a bad thing because it masks what you're really using as distribution. And so FOIL is a special case. Doesn't always work in every single situation. And so it's much, much better to know that you are relying on the distributive property and knowing how to use that rather than FOIL, which is only works in one particular case. So now let's actually do this case where FOIL fails. And we're going to use distribution, which distribution always works. So if we've got our quantity 2x plus 3 times our quantity 4x squared plus 5x plus 6, again, we're treating the 2x plus 3 as one object, and so that's going to get distributed to all three terms, to the 4x squared, to the 5x, and to the 6. So we're going to have the quantity 2x plus 3 times 4x squared plus our quantity 2x plus 3 times 5x plus our quantity 2x plus 3 times our 6. So now we'll use distribution again. Our 4x squared is going to get distributed to the 2x and to the 3. Our 5x is going to get distributed to the 2x and to the 3. And the 6 is going to get distributed to the 2x and the 3. And so that's going to give us a 2x times our 4x squared plus a 3 times our 4x squared. We're going to have a 2x times our 5x and a 3 times our 5x. And then we're going to have our 2x times the 6 and the 3 times the 6. Now we're up to the point and multiply coefficients, add exponents. So 4 times 2 gives us 8. X times x squared gives us x cubed. 3 times 4 gives us 12 times x squared. 2x, 2 times 5 is going to give us the 10. X times x gives us x squared. 3 times 5x gives us 15x. 2x times 6 gives us 12x. And 3 times 6 gives us our 18. Now we're able to combine as like terms the 12x squared and the 10x squared and the 15x and the 12x. And so as a final answer, we've got our 8x cubed plus 12 plus 10 gives us 22x squared plus 15 plus 12 gives us 27 x's plus 18. So let's do another example of those. Suppose we've got the quantity 2x minus 5 times our quantity x squared plus 3x minus 4. Well, again, we're treating the 2x minus 5 as one entity. It's in parentheses, so that's going to get distributed to the x squared, to the 3x, and to the negative 4. So we've got the quantity 2x minus 5 times x squared plus the quantity 2x minus 5 times our 3x plus the quantity 2x minus 5 times the negative 4. Well, we use distribution 3 more times. So the x squared gets distributed to the 2x, and the x squared gets distributed to the negative 5. The 3x gets distributed to the 2x, the 3x gets distributed to the negative 5, and the negative 4 gets distributed to the 2x, and the negative 4 gets distributed to the negative 5. so that we're really multiplying 2x times x squared plus negative 5 times x squared plus 2x times 3x plus negative 5 times 3x plus 2x times negative 4 plus a negative 5 times a negative 4. Multiplying coefficients, adding exponents. 2 times 1 gives us 2. X times x gives us x cubed. Negative 5 times x squared just gives us a negative 5x squared. 2x times 3x, 2 times 3 gives us 6. X times x gives us x squared. Negative 5 times 3x, negative 5 times 3 gives us a negative 15 times x. 2x times negative 4 gives us a negative 8x, and negative 5 times negative 4 gives us a positive 20. So that we have 2x cubed. Now combining our like terms, we've got the negative 5x squared plus the 6x squared, which will give us a plus 1x squared, plus a negative 15 and a negative 8 gives us a negative 23. So we got a negative 23x plus our 20. Now we can go back to our subtraction abbreviation to make this 2x cubed plus x squared minus 23x plus 20. And so one more example where now kind of the biggest multiplication that we'll do is going to be 3 terms times 3 terms. So suppose we've got the quantity x squared plus 2x plus 3 times the quantity 2x squared minus 4x plus 5. Well, again, that x squared plus 2x plus 3 we treat as one object, and so that's going to multiply all 3 terms, so that we've got an x squared plus 2x plus 3 times our 2x squared plus our x squared plus 2x plus 3 times our negative 4x plus our x squared plus 2x plus 3 times our 5. Now we're going to use distribution again, so the 2x squared gets distributed to all 3. So we've got an x squared times a 2x squared plus an 2x times our 2x squared plus our 3 times 2x squared. In the second set, we've got our negative 4x times all 3 terms. So we've got an x plus our x squared times a negative 4x plus 2x times a negative 4x plus 3 times a negative 4x. And then for the last set, we've got the 5 being distributed to all 3 terms. So we've got an x squared times 5 plus a 2x times 5 plus a 3 times 5. Okay. Multiplying coefficients and adding exponents, we have 2x squared. Our 2x times 2x squared gives us 4x cubed. 3 times 2x squared gives us 6x squared. X squared times a minus 4x gives us a negative 4x cubed. So plus our 2x times negative 4x gives us a negative 8x squared plus our 3 times negative 4 gives us a negative 12x plus our x squared times 5 gives us 5x squared plus our 2x times 5 gives us 10x plus our 3 times 5 gives us a 15. Now looking for like terms, we actually find quite a few. We've got like terms in the 4x cubed and the negative 4x cubed. We've got like terms in the 6x squared, the negative 8x squared, and the 5x squared. And then finally, we've got like terms in the negative 12x plus the 10x. And so kind of adding those together, the plus 4 and the negative 4 cancel each other out, so we have no more x cubes. So we've got our 2x to the 4th plus our 6 minus 8 plus 5 gives us a plus 3x squared. And then a minus 12 plus 10 gives us a negative 2x plus our 15. And so it's kind of a longer example, not more difficult, because you're using just the same rules that we were using before, our multiplying like bases and our distributive property. So we're using just those two rules with all of them. It's a little longer because we have more terms, but it's not more complicated. So I hope this has been giving you pretty good examples as to how you go about multiplying polynomials, and I will see you all next time.